Okay, this is section 5.7. In this section, our objectives, it's 5.7 roots and zeros. Our objectives are to determine the number of types of roots for a polynomial equation, and we're going to find the zeros of a polynomial function. All right, so stay tuned. We'll do some of this in class. It might be a little confusing, but let's just dig right into it. So, some of the vocabulary, and we'll go over the vocabulary that we're going to have is fundamental theorem of algebra, corollary to the fundamental theorem of algebra, Descartes' rule, and complex conjugates theorem. Okay, so when we had an equation, we've been doing quadratic equations, and we learned in previous lesson that f of c being some number, when it equals 0, then c is a root, or is a zero of the function, and the x-intercept. So we have some function. If you look on page 358, we have some function, and we say c, they're just giving you the different ways. You just got to be familiar with them. C, which is a solution, we can say is a zero of p of x. We can say c is a root of the solution of p of x equals 0. We can say x minus c is a factor of the function. And then we can say if c is a real number, then c comma 0 is the x-intercept of the graph. So they show you an example, and they give you the equation p of x. Remember, it's just another way for saying f of x or y of x to the fourth plus 2x cubed minus 7x squared minus 8x plus 12. If you look at the graph, you see it crosses the x-axis 3 times. And it crosses at -3, -2, -1, and 0. So we can say the zeros of p of x are these. We can say the roots are the same thing. We can say the factors are x plus 3 times x plus 2 times x plus 1 times x. Those are all the factors of p of x. Oops, not this one. Oopsie. So x plus 3, x plus 2, x minus 1. Oh, and x minus 2. I have this wrong here. And x minus 2. Okay? And we can say that the x-intercepts are -3, 0, -2, 0, 1, 0, and 2 zeros. So when we're solving a polynomial equation with a degree greater than 0, so the degree is x to the first, x squared, x to the third, x to the fourth, we say that there may be one or more real roots or no real roots, meaning the roots are imaginary. Since real numbers and imaginary are both a set of complex numbers, remember complex numbers a plus bi. We said we could have 3 as a complex number because it could be implied plus 0i, which this is 0, it's the same thing as 3. All right? So we have to go back and remember our definitions. So we said since all real numbers are both a set of complex numbers, then all polynomials with a degree of greater than 1 will have at least one root in the set of complex numbers. This is called the fundamental theorem of algebra. Now let's look at example 1 on page 359. It says solve each equation, state the number and type of equations. So they factor it and they get x plus 3 squared equals 0. You take the square root, you get x plus 3 equals 0, x equal -3. And if you look at the graph, it only crosses right here at -3. Yes? And you have one real solution. All right, and it checks right. It crosses the x-axis one time. Let's look at another one. What do we have? X cubed plus 25x equals 0. Well, I can factor an x. I'm left with x squared plus 25, which is x equals 0. X squared plus 25 equals 0, and x equals plus or minus the square root of -25, or plus or minus 5i. So what do we notice? If you look at the graph looks something like this. It's odd because this is third, it goes in opposite directions, and we have a solution, a root at x equals 0, and then we have 2 imaginary. That's why it only crosses one time. All right? So we can add to the fundamental theorem of algebra. The corollary to it says a polynomial equation of degree n has exactly n roots. So if it has a degree of n, it has exactly n roots. For example, we have a polynomial that has a degree of 5, excuse me, it's going to have 5 roots. Now, they can be imaginary, they can be real, excuse me, they can be a combination of both, real or imaginary. All right. Now, there's a man named René Descartes. He discovered a relationship between the signs of the coefficients of polynomial function and a number of positive and negative real roots. We're going to end here, and we'll do a part 2 to this video.